All right, guys, another day. I'm not going to be here. These are our notes for today. A-4, we're talking about similar triangles. And, if you go back to the definition of two polygons being similar, they have to have these two criteria that are met. Corresponding angles have to be congruent, meaning they have to be exactly the same. And corresponding sides have got to be proportional. Okay, just like what we've been working on 3-2 and 8-2 and 8-3, proportional. Now I'm just using the symbols there. This is the symbol for congruent. This is the symbol for proportions. Okay, we're going to talk today about whenever we're dealing with triangles, we can take some shortcuts in determining that two triangles are similar. Yes, these criteria have to be met, but understanding these shortcuts, we can jump to the conclusion that they are similar triangles a lot faster. We'll start off with the angle similarity. The A here stands for angle. These are angle similarity. And this shortcut here is that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Once again, I'm using symbols instead of writing down the vocabulary words. So I'm going to read this again. Angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. What this means is that if we can match up two angles to each other, then the third angle has got to be congruent also. Okay, now why is this? Well, if all three angles have to add up to 180 and these two angles are the exact same as these two angles, then what's left out of the 180 is going to have to be the same in both triangles. So like I said, it's a shortcut. As long as you can prove that two angles are congruent in the triangle, then the third one we know is going to be true. So here's two examples of angle similarity. If you notice right here, we have two vertical angles. That's our kissing fish rule right there. And then we have the box here telling us that C and B are 90 degrees. So we have angle similarity. This is a yes. These two triangles would be similar. Now we got to be very careful on how we name this. If we look at this and let's say ACE, I'm going to give Ace Hardware a shout out for giving me free Dr. Pepper all the time. ACE. Now, what I have to be conscious about here is that my corresponding sides are going to match up. My corresponding angles are going to match up. So what angle corresponds with A? And that's going to have to be the D. So this would be D. C is next. C was that 90 degree. So B on this one. And then last, the two here are the same. The E is the same. Those are the vertical angles that we're looking for. So once again, we had angle similarity. Two angles, we knew that had to be congruent. Okay, so now let's go back over here. On this one, we're going to prove this. We're going to reflect back onto parallel lines. And we have our zigzag pattern here. And our zigzag tells us that J is congruent to F, because that makes that N shape. Okay, I also have my kissing fish right here, my vertical angle. So H and H are going to have to be the same. Now that's enough to prove angle similarity. Okay, but I still, just because I know parallel lines and the zigzag patterns that we get is pretty easy, I can show that there's my zigzag and that K and G have to be congruent. Once again, when we name these triangles, when we're writing them down here, we have to be conscious about J matches up with what angle over here, and that would be F. So as we name this, let's name this JKH. Now, how do we need to name this one? J matches up with F. K matches up with G. H matches up with H. So hopefully you caught on to that pretty quick, but the order here is very important. Okay, we're going to use angle similarity to find the missing measurements in this triangle. So given, here's a very important piece right here, that AB is parallel to CD. That gives us our zigzag. So we know that A and D make the N shape, zigzag. And then we can flip that and we can know that B and C make that zigzag pattern. Okay, but also because of that kissing fish rule way back when, I told y'all that was a big thing that a lot of people remember the kissing fish, we automatically know that E's there too. So we can quickly do angle, angle, and know also that we have all three that are congruent. All right, now the missing measurements here, let's see, A to B is 4, A to E is 3x plus 1, CD is 8, and x plus 12 is from E to D. Okay, remember me telling you how important it was to set these things up? This is triangle, we could say A, B, E is similar to triangle, let's see, A is going to be with D. That's a D. This is triangle. D, let's see, B is going to be with C, and then E, okay? Now, what sides correspond with each other? We can jump to the conclusion pretty quick that 4 and 8, but if I notice that I have my arc marks here, 1 and 2 arc marks, and as I go from here, 1 and 2, these are 2 correspond to each other. Let's set this up as big over small. Still working those proportions from A-2. So this is going to be 8 over 4, and that simplifies down to 2 over 1. I want to leave it as a ratio. That's my common ratio right there. All right, now I want to solve these two. Okay, notice this is going from 1 to 3. 1 arc mark, 3 arc marks. So as I set this up, there's my common ratio. The big triangle is going to go first. X plus 12 is on top over 3x plus 1. These are proportional to each other. Okay, now how do we solve proportions? The method is called cross multiplying, but because there's 2 terms on top here, I have to make sure that I distribute this 1 to both terms, and I got to make sure that I distribute this 2 to both terms on the bottom. So across the top, x plus 12. On the bottom, 2 times 3 is going to be 6x. 2 times 1 is 2. Now I want to solve for x using my algebra steps. X here is the smallest variable out of that, so I'm going to subtract an x from both sides. There's my equal sign. I'm going to go ahead, since I'm putting all my x's on the right, I'm going to go ahead and get rid of this 2. And I'm going to subtract 2 from both sides. Now I have 10 equals 5x, and then I want to solve for x by dividing by 5. 10 divided by 5, 2 equals x. So we found x, and that's great, but they want us to find A to E. A to E, I'm going to have to take that x back in and plug it into there. So A, E is going to be 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. Okay, then D, E, the distance there for that one, is going to be x plus 12. Well, that's 2 plus 12, which is 14. So my answer here should be 7 and 14. All right, so a second way that we can show that triangles are similar is by looking at side, angle, side. So the S here in SAS stands for side. The A still stands for angle. And then the last one here, it's an S, it starts with side. Okay, now with this one it says that in 2 triangles, if a pair of corresponding angles is congruent, angles are congruent, and the sides including, remember that word means between, including the angle, so the sides that the angle is between are proportional. That's our symbol for proportion. Then the triangles are similar. Okay, so I use some abbreviations there. Gonna reread this. Side, angle, side, similarity. In 2 triangles, if a pair of corresponding angles is congruent and the sides, including the angle, are proportional, then the triangles are similar. Here's an example. Okay, these 2 sides here correspond to each other. These 2 sides here correspond to each other, and the angle here is congruent to each other. They make a sandwich. An angle, a side, angle, side sandwich right here. Okay, the angle is in between the 2 sides. All right. Can the two triangles be proven similar by side angle side? So as we look at this, right off the bat, I noticed that, hey, they both have that 120 degree angle. So we have the angle. Now we need to see if the sides are proportional. So 4 and 6, and then 6 and 9. Since they're written like this, I'm going to go small to big. Small to big. Okay, so 4 over 6, 6 over 9. We can see now, do these two things simplify down to the same number? 4 over 6 would simplify to 2/3, and 6 over 9, if I simplify by 3, that would also go to 2/3. So yes, even though they're different here, they simplify to the same number. So this is, yes, by side, angle, side similarity. MNL. I guess I could have used alphabetical order there, and that might have been better, but it doesn't matter. What matters is that on this next one, we name it by the corresponding angles. So M corresponds with P, N corresponds with R, L corresponds with Q. And then, like I said, it doesn't matter. We could have said L, M, N, and then we would have rearranged this one to the appropriate side. So that's your side angle side similarity. Okay, the third way that we can look at this is by using SSS. This is side, side, side similarity. Okay, so you can imagine here, we're going to only look at the sides. If all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. And that's our symbol for proportional, that's our symbol for similar. If all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. So here's our example. On example 4 here, we want to show by side, side, side. Notice we don't know anything about the angles, so this gives us a way that we can prove that these triangles are similar, okay, without knowing the angles. As we go through here, we want to find out which sides correspond with each other. The 3 and the 9, the 5 and the 15, the 4 and the 12. So I set up my ratios here, and you could do small to big or big to small. It doesn't matter. I'm going to do small to big since it's left to right. And so we have 3 over 9. Those two corresponds. If I simplify that, that is 1/3. 5 over 15. These two correspond with each other. So 5 over 15, simplify by 5 on both, top and bottom, I get 1/3. Okay, and then the last here is 4 over 12, which if I simplify the top and the bottom by 4, I get 1/3. So we do have a common ratio between all of our proportions there. And so this is a yes, okay, by side, side, side. Now, 3, 5, 4, I'm going to go STU. And just like all the other ones, we have to make sure that our angles correspond, our names correspond with each other on this side.